Okay, so we are on unit 10.3.
Hello, Will.
Okay, the first part of what we're going to do today is probability of single events. Probability of single events. So of one thing happening. Okay, the probability of one thing happening. Okay, first thing you need to know is that probability is equal to what you want happening, divided by the total possible outcomes. Okay, so what you want divided by the total possible outcomes. Okay, there are also some rules of probability that you need to know. Okay, a couple rules of probability. Okay, probability is always in between 0 and 1. Okay, so the probability is always in between 0 and 1. Most of the time, we will write this as a fraction. Okay, so we'll be writing probability as a fraction. Okay, another thing you need to know about probability is that the probability of an impossible event, and we write that as a subscript, okay, probability of an impossible event, what do you think that's equal to? What's the probability of an impossible event? Probability of something never happening, what do you think that would be equal to? Could it be less than 0? No, that would be negative. There's no negative probability. 0. Exactly. So the probability of something that is not ever possible happening is 0. Okay? The probability of what we call a certain event, so probability that something is definitely going to happen is what? 1. Exactly. Okay? Generally, your probability is going to be in between those. So it's going to be a fraction usually. Technically, we could write those as a decimal or as a percent, but usually we're going to end up writing things as fractions. Okay, so those are your kind of main rules of probability. You also need to know that the sum of all probabilities for all possible outcomes must be 1. Okay, so all the different things that could possibly happen, if you added up all of their probabilities, it must equal 1. Okay, has to equal 1. So, first thing we're going to go over is rolling a dice. Okay, so rolling dice. Okay, so we're going to go over a couple different kind of scenarios. The first one is rolling dice. So, if for example if you just roll 1 die, okay, plural of dice, so 2 dice is considered, 2 are called dice, 1 is called a die. Okay, so if you roll 1 die, I want you to find the probability of rolling an even number. What is the probability of rolling an even number? So, if you roll dice, what are the possible outcomes? 1 through 6. So, how many outcomes are even? Okay, rolling dice, you could get a 1, a 2, a 3, a 4, a 5, or 6. So, there's 6 possible outcomes. So, your total possible outcomes is 6. How many of those are what I want, an even number? 1, 2, 3 of them. So 3 and 6. So your probability, if you reduce that, would be 1 and 2. Okay, so you have a probability of 1/2 of if you rolled 1 dice to get an even number. Okay. Let's try another one. What if I asked you to roll, again, roll one die. Okay, I want you to find the probability of getting a number less than 4. What is the probability of getting a number less than 4? The probability of getting a number less than 4. How many different ones are less than 4? 3. Out of a total of 6. So all you're doing is figuring out how many favorable outcomes there are divided by how many total outcomes there are. Okay, how many favorable outcomes divided by how many total outcomes. I'm sorry, what was your question?
I can't see it.
You can't see it. Okay, let's try just a couple more. What is the, again, we're rolling one dice. What is the probability of getting a number greater than 6? What's the probability of getting a number greater than 6? Is it possible to get a number greater than 6? No, so 0 out of 6. Okay, so this is what we would call a what? Impossible event. Okay, an impossible event. You could say impossible or a never event. Okay, that's never going to happen. So an impossible event. Okay, last one for this part. I want to find what is the probability of not rolling a 1. What's the probability of not rolling a 1?
Very good. 6.
Okay, the way you do this is whenever you have something called a not, okay, there's a formula for this. It's probability of a not, okay, if you have a bar like that that says not. So probability of not getting something is equal to, what's the total probabilities of everything? 1 minus the probability of getting what it is you want. So to do this, you would get 1 minus, what's the probability of rolling a 1? 1 in 6. So the probability of not rolling a 6 would be 1 minus 1 over 6. So get the same denominator. That would become 6 over 6 minus 1 over 6. So what's the probability of not rolling a 6? Or a 1, excuse me? 5 out of 6. Exactly.
Do we have to do that, or could we
You will definitely have to do this, yes. Okay, for instance, you're going to be given a probability. Okay, you're going to be given a probability. So, for instance, okay, let me show you another one like this. Okay, this is not with rolling dice, but if you are given, for example, number 2, okay, if you are given that the probability of getting an A or a B in my class, excuse me, the probability of getting an A or a B in my class is equal to 3 and 5. Okay, probability of an A or B in my class is equal to 3 out of 5. The probability of getting a C or a D in my class is equal to 3 and 10. I want you to find the probability of getting an F. Probability of getting an A or B is 3 and 5. Probability of getting a C or a D is 3 and 10. Find the probability of getting an F. And we're assuming the only grades you could get is A, B, C, D, or F. So no incompletes, nothing like that. So the way you do this is you take total probabilities is 1 minus probability of getting an A. So 1 minus 3 over 5 minus the probability of getting a C or a D, which is 3 out of 10. Now, if we convert all of these to have the same denominator, what's my common denominator? 10. So what is 1 in tenths? 10 out of 10. Minus, what is 3 out of 5 in tenths? 6 out of 10. Minus, this one was already written in tenths. So 10 minus 6 minus 3 gives you what? 10 minus 6 minus 3 gives us what? 1 in 10. So the probability of getting an F would be 1 in 10. Okay, so you can find other probabilities based on what you were given. Okay, so yeah, that one that I just gave you, you could know, okay, like on this other one, well, the probability of not rolling a 1 is equal to getting a 2, 3, 4, 5, or 6, so 5 out of 6. But for this kind, you do need to know how to do the whole number subtracted. Okay, so you will need to kind of know how to do both ways. Okay? Next stuff that we're going to go over is when we're dealing with a deck of cards. A deck of cards. So, if you are given a deck of cards and we are going to pick one card. Okay? You're given a deck of cards and we're going to pick one card. For example, number 3, I want you to tell me what is the probability of picking a black card. Now, just in case you're not very familiar with decks of cards, there is a poster up on the wall. Okay? You need to know that in a deck of cards there are 4 suits. Okay? There is hearts, diamonds, clubs, and spades. Okay? 2 of them are red, 2 of them are black. There are 13 cards in each suit, so that makes a total of 52 cards in a deck. Okay? We're not counting jokers or anything like that. There's 3 face cards in each suit. There's 4 suits, so there's a total of 12 face cards. So you do have to be a little bit familiar with the deck of cards. So if I gave you, what is the probability of if I picked out one card that it was a black card? How many total black cards are there? 26, because there's 13 of 2 suits. So 13 plus 13 is 26, divided by how many total cards? 52. So you have a 1 in 2 chance of picking a black card. Okay, a 1 in 2 chance, or 1 in 2 chance of getting a black card, correct. Okay, what is the probability of picking a king? What's the probability of picking a king if I only picked one card?
Extremely low chance.
How many different kings are there in the whole deck? 4 out of how many total decks? How many total in a deck? 52. So if that reduced, you would be 1 in 13. Okay, what's the probability of picking a diamond? What's the probability of picking a diamond? How many total diamonds are there? 13 out of how many total cards? 52. That reduces to 1 in 4. And then the last one I know is what is the what is the probability of getting a 6 of clubs? How many 6 of clubs are there? Just 1, divided by how many total cards are in a deck? 52. Okay, that's it. That's it. Okay. So those are cards. So decks of cards. Okay, decks of cards. You do need to be a little bit familiar with decks of cards. Okay. Next thing we're gonna go over are marbles. Okay, if we have a bag of marbles. Okay, with marbles, if you are given a bag containing, if you're given a bag of marbles containing 6 white, 3 blue, and 7 green marbles. Okay, if you're given a bag that contains 6 white, 3 blue, and 7 green marbles. Okay, and we are going to pick 1. Okay, picking 1 at random. What number are we on? Number 4? Okay, so for example, number 4, I'm going to find if I have a bag containing 6 white, 3 blue, and 7 green marbles, and I'm picking out 1. What is the probability of picking a white marble? What's the probability of picking a white marble? How many total are there whites? 6 out of how many total marbles are there? 6 plus 3 plus 7 is 16. So that would reduce to be what? 3 out of
Over 8.
8. Okay, just a couple more. What's the probability of picking a marble that is not green? The probability of picking a marble that is not green. Not green means 1 total minus how many are green? 7 out of a total of what? 16 total. So what's your common denominator here? 16. So 16 out of 16 minus 7 out of 16 gives you what? 9 out of 16. Okay, and then
Not add the 7 green.
you could add the other ones up if you wanted to. But sometimes you're going to be given bags that have like 100 marbles in them. So it's a lot easier to just figure out 1 minus something than to add up all the
If
others.
it asks how many are not there, wouldn't you just subtract that?
That's what I just did. So 1 minus the probability of yes being green.
Why do you have to? Oh,
We had to get a common denominator. Okay, and then the last one I want you to find is find the probability that your marble is blue or green. Okay, find the probability that your marble is blue or green. So, whenever you see the word or, do you know what is that going to mean? Or means that we are going to add things together. So you have to find the probability of blue and add to that the probability of being green. So what is the probability that your marble would be blue? How many blue marbles are there? 3 out of total of 16. Plus, how many green marbles are there? 7 out of a total of 16. So the probability of being blue or green, add those together, would be 10 out of 16. And that reduces to what? 5 out of 8. Right? Your homework for this is going to be, you're going to do worksheet 3, numbers 1 through 14. You are also doing page 701 in your book, numbers 3 through 5, and 11 through 16. So worksheet 3, numbers 1 through 14 in your green book, and page 701, numbers 3 through 5, and 11 through 16.